Within. Good morning, children. Today, continuation of the permutations and combinations. SIQ is already started now, so remaining continuation. So now just for some concepts, permutations under restrictions. So when particular objects are always together. So and another one is when particular objects are never together. So in both cases, first case we have to consider as object as one unit, then proceed the permutation. How will we yesterday continuation of the class? Same thing. That's why we have to do. And the particular things are not never together means it should not be in the same way. So have to keep as gap method. So this is the permutations under restrictions. So in this manner, today the questions are from sixth onwards is there. That's why I'm saying sixth to remaining. So the question is given that find the number of ways of arranging 5 different mathematics books, 4 different physics books, and 3 different chemistry books, such that books of the same subject are together. This is the property of permutations under condition, under restriction or condition. So when a particular thing is always together and never together. So this is has to be in the question number 6. The question is given, find the number of ways of arranging 5 different mathematics books, 4 different physics books, and 3 different chemistry books, such that the books of the same subject are together. So always together. So same subject, keep it as and the together. So first let us keep as a how many are given in the question. So five math books, 5 mathematics books, and next one is 4 physics books and 3 chemistry books. So the question such that the books of the same subject are together. So 5 mathematics books means let us take it as M1, M2, M3 like this, M4, M5. And 4 physics books means P1, P2, P3, P4. Chemistry books means C1, C2, C3. In the question is given that such that the books of the same subject are together. So all subjects together and physics subject are together and chemistry subjects are together. So how many things are these? 3 things. So it can be done in 3 things means as MPC. So 3 subjects. So subject wise we have taken it as maths, physics, chemistry. This can be done in 3 subjects is there, 3 different books. That means it can be arranged in form of 3P3 or else 3 factorial. So this is the first mathematics books, physics books and chemistry books. One of the subject MPC, subject by saying, so it can be done in 3 factorial ways. either MPC or CMP or PMC, like this. So that means 3 factorial means we get as 6 na. So either MPC or CPM, physics, total things are we get as 6. And similarly, always this M1, M2, M3, M4 as in the, not in the same order. So it will be among themselves. It will be some another permutation will be occurs. So let it be as how many are mathematics books. So mathematics books can be arranged among themselves is 5 factorial. Why? Because not in always M1, not in always M2, M3, M4. So it will be among themselves as a mathematics wise. It can be done in 5 factorial ways. And similarly, physics books also P1, P2, P3 not in the same disorder. It will among themselves can be arranged in how many are there? Four physics books are there. So physics books can be as per subject. So that can be 4 factorial. Next, chemistry books also always not be in the C1, C2, C3. Internal arrangement. This is called internal arrangement. So it will be in the same of C can be arranged in three C1, C2, C3. Three subject means it can be permitted in 3 ways. So therefore, total arrangements are total elements can be done in 3 factorial into 5 factorial into 4 factorial into 3 factorial. This is the total arrangements of the same subject are together. So that is why what we have in the question is given. Find the number of ways of arranging 5 different mathematics books, 4 physics books, and 3 chemistry books are, and such that it is given same subject always together. Same subject always together means this has to let it be M1, M2, M3, M4, M5. This has P1, P2, P3, P4, and C means C1, C2, C3, like this. So first, always not in the same order, MPC. So either maybe starting with physics, either chemistry or maths. Like this, total how many things will can be occur? That is 3 factorial. 3 subjects is subject wise means MPC is there. So that is right. We treat as a 3 factorial base. And remaining always starting with M1, M2, M3 not different among internal arrangement of mathematics books. So 5 books are there. So it can be done in 5 factorial ways. In similarly, physics books also not in the same P1, P2, P3, P4. The internal arrangement of the physics books always can be done in 4 factorial ways. In similarly, chemistry books always done in 3 factorial. So total number of ways of arranging same subject are together is so 3 factorial, 5 factorial into 4 factorial into 3 factorial. So this can be form of the question. So that is why this way I am writing here. Yesterday I already told I am explaining this side and left side also write it as a like this way. So 5 different mathematics books are arranged in themselves in 5 factorial ways. 4 different physics books are arranged in themselves in 4 factorial ways. Similarly, 3 different chemistry books are also arranged in themselves in 3 factorial. So therefore, the question is asking that the number of arrangements such that the book of the same subject are together is total multiplication. Then you get this is the answer. Okay. But the question is given, you think first. Find the number of ways of arranging 5 different mathematics books, 4 different physics books, and 3 chemistry books such that the same subject are together. So that is why first we have written as the number of ways of arranging mathematics, physics, and chemistry books are arranged in 3 factorial. Why? Because 3 factorial as per subject arrangement, either MPC or else CPM, like this. So how many ways you can get? That means 3 factorial ways as per subject wise. And similarly, next go to mathematics books not in one. Total books are 5. So internal arrangement of the mathematics books can be done in 5 factorial. Similarly, physics can be always not in the form of P1, P2, P3. Like this to P2, P1, P3 like that. So how many ways that it can be done in 4 books are there. So that is 4 factorial ways. C1, C2, C3 nothing but internal arrangement of chemistry books done in 3 factorial. That is why like this you have to write, and left side also you have to write in the IP model. So everything explained in the every time question, every question should be explanation is the important. Okay, this is the question number 6th question. In similar way, so write all these. So 5 different mathematics books, 5 factorial ways, 4 different physics books, 4 factorial ways, 3 different chemistry books in 3 factorial. Therefore, the number of arrangements such that the books of the same subject are together is, so like this, 3 factorial into 5 factorial into 4 factorial into 3 factorial. So total value becomes to 103680. Let's see the question number 6. In similar way, question number 7 is also there. So find the number of ways of arranging 6 boys and 6 girls in a row. In how many of these arrangements all the girls are together, no 2 girls are together, and third question is given that boys and girls come alternatively. So find the number of 6 boys is given. 6 boys and 6 girls. 6 boys and 6 girls is given. So that is in this how many ways can be done in? Find the first statement. The number of ways of arranging 6 boys and 6 girls in a row. So that is why total number becomes to 12 persons. 6 boys and 6 girls can be done in 12 persons. So this can be done in a row. They are arranging in the row wise. So that is why it can be done in 12 factorial ways. 12 factorial ways. And first question is given that in this first question, all the girls are together. 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 So that is all the girls are together means always make a bundle or one unit. Take it as treat as a 6. All the girls means all the girls has 6 boys and 6 girls are there. So 6 girls as one unit. 6 boys. Then we have 6 boys plus 1 unit of girls. 1 unit of girls. So 1 unit of girls. So totally it becomes 7 things. 7 things can be arranged in 7 factorial ways. Okay. All girls are together means always it should be in the form of 1 unit. So treat as the 6 girls as 1 unit. So remaining 6 boys plus 1 unit of girls. So total things are becomes to 7 things. These 7 things can be done in 7 factorial ways. And then internal arrangement always the girls in the same way. Same pattern. So they will internal arrangement of girls should be occurs. That means 6 girls can be arranged among themselves nothing but 6 factorial ways. Therefore, the total arrangements of the all girls are together means write as 7 factorial into 6 factorial. So all the girls are together means all the girls sit in the one place only. That's why treat as 6 girls as 1 unit. This is the method, permutations of restriction, first method. So all the girls come together means always treat as the 6 girls. Anything, 6 not here, 6 girls. If it is given that all are together means make a bundle, that's all. So that is treat the 6 girls as 1 unit. Then we have 6 boys and 1 unit of girls. So this total things can be done in 7 things are there. This can be permuted, that is 7 factorial ways. Then the 6 girls always in the same pattern. They will be arranged among themselves. This can be done in 6 girls can be done in 6 factorial ways. Therefore, the total arrangements are 7 factorial into 6 factorial. So that is why we have written as here number of girls is 6, number of boys are 6, number of girls is 6. So the number of ways of arranging they are in the question is given. So 6 boys and 6 girls are altogether 12 persons. They can be arranged in a row is 12 persons can be done in 12 factorial ways. And all the girls are together. All the girls are together means treat the 6 girls as 1 unit. Treat the 6 girls as 1 unit. Then you have 6 boys and 1 unit of girls. They can be arranged in 7 factorial ways. Total things become 7 things. So this can be done in 7 factorial. The arrangement of 6 girls are always not in the same manner. So it should be arranged among themselves. 6 girls can be among themselves is nothing but 6 factorial ways. So therefore, the number of ways in which all the girls are together is 7 factorial into 6 factorial. So that is the question number 1. Now go to the second question. No two girls are together. In previous, all girls should be in the together. So they will be seated as one bundle. But here in the question is given that no two girls are together. So compulsory the condition is given that no two girls are together means should not be make a bundle of the girls. So first you have to arrange 6 boys. The condition is given, so that is why 6 boys. 6 boys means they are in the row wise. Row wise means it can be done in 6 factorial ways. So that is why I am just giving 1, 2, 3, 4, 5, 6 boys. So the boys 1, boy 2, then boy 3, boy 4, boy 5, boy 6. So first arrange. Why? Because no two girls are together. So first arrange the first boys in the row wise. That can be done in 6 boys are there. So they can be arranged in 6 factorial ways. Not in the B1, B2, B3, B4, B6. In the number of arrangements will be occur say different. That can be arranged in 6 factorial ways. So no two girls are together means you have to gap method. You have to in between the gaps we can find. So 1, 2, 3, 4, 5, 6, 7 gaps will be occurred. So in the we can find the 7 gaps between the boys. In this place we have to arrange the 6 girls. So they can be arranged in. So how many girls are there? 6 girls. 6 girls are there. 6 boys and 6 girls. So how many gaps are formed? 7 gaps are formed. In these 7 gaps, we can say arrange as 7p6 ways. 7 places, 6 girls. 7 places, 6 girls, nothing but we can arrange as 7p6 ways. Therefore, the total number of ways in which no two girls are together means 7p6 into 6 factorial. So 6 boys first, no two girls are together means first arrange with boys. Number of boys are 6. So 6 boys can be in the row wise. This can be done in 6 factorial ways. Then we can find how many gaps between them. Why? Because taking gap, no two girls are together means you have to arrange them in between the boys. So in this in between means how many places we can find means 6 boys are there, we can get n plus 1. That is 7 ways. 7 gaps are there. 7 gaps between them. So in these 7 gaps, we can arrange 6 girls can be done in 7p6 ways. Therefore, the number of ways in which no two girls are together is 7p6 into 6 factorial ways. Question, read question Nana, just you think once, then you get an idea. So first read the question. What is the question is given? We have the how many number of people are there. So first no two girls means you have to arrange them with boys. So with in a row. It is not in the another way. So it is in they should be seated in the linear form, that is in the row form. So the boys will be always done in 6 boys are there, so it can be done in 6 factorial ways, and the remaining no two girls are not come together means you have to get the gaps in between them. So how many gaps we have? We can find 7 gaps. So in these 7 gaps fill with 6 girls, so this can be done in 7p6 into total answer means 7p6 into 6 factorial. This is the question number 2. This is a very important question for IP examination. So write all those. I am giving the clues of the same right side. You have to write all those explanation in the exam. Okay, that's why I'm written as before only. So total things you have to write and learn. Next, go to the third question in this sixth one. So boys and girls come alternatively. Boys and girls come alternatively means, so first either may row begin first starting with boys, or boys is the one way, and second the row may begin with as girls also another way. So this carries how many ways? Two ways. So boys and girls come alternatively means the row may begin with as with either a boy or a girl. So that is why I am having completed here. So boys will be starting, suppose. So in a row means you have to arrange them as boys. 1, 2, 3, 4, 5, 6 boys. 6 boys means 6 boys are there. 6 boys means it can be done in 6 factorial ways. Okay. Next, boys and girls should become alternatively means. So in this now, alternatively means don't take this first place. Boys and first in these gaps you have to fill in between them. So that is why. So for boy, girl. The row first start with boys means you should take only first boys. So total boys are 6. 6 means it can be done in 6 factorial ways. And remaining in between alternative means you can get a in between means in between you have boys and boy in between girl should be applied, occupied the place. So that is why how many girls are there? 6 girls. So this is in way the girl should be done in 6 factorial ways. This is the first way of with the start. The row may begin with eyes with the boys. And the second way, the row begin with 6 girls. So 6 girls means starting with girls G1, G2, G3, G4, G5, G6. So the row may begin with 6 girls. 6 girls can be done in 6 factorial ways. And the next one in between boys will be occupy the place. So boys will be occupy the place. So this is nothing but this also 6 factorial. So either this way or this way. The row suppose starting with boys means it should be in the form of this like this way. Or else the row may begin with as girls only. This is the another way. Already I written on that side. So that is why. So this total how many things are girls with, this is the first case and this is the second case. So the girl, boy, girl, boy, girl, boy, girl, boy. The row firstly begin with boys and girls come alternatively. The ways are to be in form of two cases will be appear. So that is starting with boys or starting with girls. 1, 2, 3, 4, 5, 6. That is why these cases are two cases. Therefore, the number of ways in which boys and girls come alternatively is 2 into 6 factorial into 6 factorial. So that is the explanation of this question. Boys and girls come alternatively means the row may begin with either boy or a girl. In how many ways? Two ways. The row may begin with boy means first you take boy and then girl, then boy. Like this, 6 boys and 6 girls. And the second way also starting with the row may begin with either with girl. So this can be done in first way, second way. The internal arrangement of the boys is 6 factorial and the 6 girls can be arranged in 6 factorial. So therefore the total number of ways is 2 into 6 factorial into 6 factorial. This is the question number 6. This is the most important. So that is 6 boys and 6 girls in the row form, either starting with first question girls are together and second question is no two girls are together and third one is boys and girls come alternatively. So read the question first, simply first read the question. Find the number of ways of arranging 6 boys and 6 girls in a row. In how many of these arrangements girls are together, no two girls are together, boys and girls come alternatively. So in the row form means in the first statement is given in a row, the arrangement she is asking. So totally the persons altogether make a 12 persons. 12 persons we have to arrange them in a row. That's why we write as 12 members can be done in 12 factorial ways for the first statement in the question. Next go to the all the girls are together. All the girls are together means treat as the all the 6 girls as one bundle. So then we have that is 6 boys and 1 unit of girls. So total things how many are there? 7 things. These 7 things can be done in 7 factorial ways. Then go to the 6 girls. 6 girls can be arranged in 6 factorial. The 6 girls should not be in the same way. G1, G2, G3, G4, G5, G6 or else starting with G2 internal arrangement of the girls. So that is why it can be done in 6 members are there in a row means 6 factorial only. So therefore the answer, total answer becomes to all the girls are together means 7 factorial into 6 factorial. This is the first 6th bit, 7th bit, sorry, 7th bit, first question. Then second one, 7th second one. No two girls are together means first no two girls are given. That is why we have to select first arrange the 6 boys in a row in how many ways? 6 factorial ways. Then in no two girls are together means in between you have to arrange them with girls. So that is why if how many gaps we can between them is 7 gaps will be appear. So in between 7 gaps we can arrange with 6 girls. So they can be arranged in 7p6 ways. The total answer is the number of ways in which no two girls are together means 7p6 into 6 factorial. And then go to the third question. Boys and girls come alternatively. Just you think, boys and girls come alternatively means you can, the row first may begin with either with a boy or a girl. It can be done in 2 ways. The row first way is begin with boys, that is the first way. And the second way is the row may begin with as girls, that is the second way. Therefore, the boys are treated like this. This can be arranged in 6 in a row means 6 factorial ways, and 6 girls can be arranged in 6 factorial. So total answer is 2 into 6 factorial into 6 factorial. This is the question number 7. Then go to the question number 8. In the same way, like this, all these are same method. So the permutation with under restrictions. First one is come together, and second one is never come together. That is the same. All are same pattern. Just to think and write. That's all. That is the matter of the second problem we have to do. But in the explanation in the exam is necessary. Now that's why I'm writing here. This 8th one. Left side only total explanation is given. All these problems. Okay. Find the question number 8. Find the number of ways of selecting 10 students A1, A2, A3, so on A10 in a row such that first question A1, A2, A3 sit together, and second one is specified order A1, A2, A3 in a specified order. So third one is A1, A2, A3 sit together in a specified order. So how many are there? The number of ways of seating 10 students are there in a row. So we have to arrange them in a row such that sit together is the first question, and the second one is in a specified order. That means A1, A2, A3 always that is in order. So that is A1, A2, A3 sit together and in specified order. These 3 questions are there. In previously we already we done it in the same pattern. We have to write same thing, same method only. So first, the how many students are there? Here A1, A2, A3, so on up to how many are there? Totally 10 students. So that is the 10 students. First question is given such that A1, A2, A3 sit together. Sit together means always you treat as a one bundle or one unit, anything. How many are there? three are there, 3 persons. A1, A2, A3 as one unit. So first one A1, A2 and A3. So this can be as one unit. Why? Because we are taking one unit. Sit together. A1, A2, A3 sit together means treat as a one unit. So then How many are there remaining? 3 are 1 unit we have taken. So remaining are A4 to up to A10. So total of how many members? 7 persons are there. 7% plus now we have taken as 1 unit. Totally 8 units. So 8 units can be occurred. So these 8 things can be in how many arrangements will be formed? 8 things can be done in 8 factorial ways. Next, A1, A2, A3 treat as 1 unit now. They are not in the same order. A1, A2 is not in the same order. They will be internal arrangement of these 3 persons. It will be occur how many ways? Either 1, 2, 3, nothing but 6 ways will 1, 2, 3, 2, 3, 1, 3, 1, 2, 2, 1, 4, 2, 1, 3, 3, 3, 1, 2, 2, 3, 2, 3, 1. Like this, how many we can get? 6 ways. That is should be 3 factorial. So it can be done in among internal arrangement of this. Internal arrangement is 3 members are there, that is 3 factorial. Therefore, the total arrangements are 8 factorial into 3 factorial. So in the first question, so what is the question is given? Find the number of ways of seating 10 students in a row such that A1, A2, A3 are sit together. In a row means how many are there totally? 10 students means you get as 10 factorial ways. That is not a way. The question is given A1, A2, A3 is A1, A2, A3 is sit together. So A1, A2 sit together means treat as A1, A2, A3 as 1 unit. Then we have remaining students starting with A4 up to 10. Total how many get? 7 persons. 7 persons means 7 persons can be done. Total things will be what? 7 plus 1, that is 8 units. These 8 units can be done in 8 factorial ways. Then the unit of 1, 2, 3, A1, A2, A3. Always this is not in the same order. So 1, 2, 3 becomes to interchange will be internal arrangement of these 3 persons will be can be arranged. So that how many internal arrangement make them is 3 members are there means you can arrange them as 3 factorial. So therefore the total number of ways of A1, A2, A3 sit together is 8 factorial into 3 factorial. That is the answer. Now permutation with restriction means the first property is under restriction means always come together. Just you remember always come together means you should take as 1 unit. That's all. The question is in the different ways. Similar a 7th question and then 6th question are both are same. So always come together means treat as 1 unit. So here also given that total 10 students A1, A2, A3 are sit together. So that is why treat as A1, A2, A3 as 1 unit. So that is the 1 unit. So remaining means how many persons are there? A4, A5, A6, A7, A8, A9, A10. Total how many persons means 7. These 7 persons and 1 unit of A1, A2, A3. So that is nothing but total how many units? That is 8 units. 8 units can be done in 8 factorial ways. A1, A2, A3 are always not in the same order. So they will be differ them. So this can be done in 3 factorial ways. Therefore, the total number of ways A1, A2, A3 come together is 8 factorial into 3 factorial. This is the question number 8 first bit. In the similar way, second one is A1, A2, A3 in a sit in a specified order. A1, A2, A3 sit in a specified order. Specified order ante that means A1 should be first, A2 should be first, or else A3. These 3 persons are there. 3 persons always in the VIP, like this VIP nana. First VIP, second VIP, third VIP. Just in the row, they will be arranged in the row. So first one they call as A1 and second then go to the VIP2 and say third one will go to the VIP3. This total how many positions to sit there in the same order, specified order means in this order only they will arrange them only. So that is A1, A2, A3 can arrange in how many positions? 10 positions. In this anyone can sit in the 10 positions. So the 3 persons left over, how many places will be remain? 7 persons. So 7 persons remaining, total 10 positions will take in how many ways? This can be done in 10p7 ways. This is the specified order. And third one is A1, A2, A3 sit together in a specified order. So compulsory in the form of always treat as this thing should not be changed. That is no in the internal arrangement of this. Always in that not difference of the A1, A2, A3, 2, 1, A1, 2, A2, 1, 3, not in the same. That is no way, no changes of in the A1, A2, A3. Always this as a bundle. A1, A2, A3. Always keep it as a one unit. That is why treat A1, A2, A3. That is in that order as in that order only. There is no change of A1, A2, A3. There is no change in A3, 2, 1, 8 like that. Always this method only, this order as one unit. Now there are how many? 8 objects. So why? Because it has one unit, remaining 7%. 7% plus one unit. So totally how many? 8 units. 8 units nothing but they can be arranged in 8 factorial. Always that A1, A2, A3 in the same pattern. That means nothing but they are in the 1 factorial. Nothing but they will be of the they can be arranged in specified order is 8 factorial. So my big question reads properly A1, A2, A3 sit together in a specified order. So that is there is no change in the order of the persons A1, A2, A3. That is why this in that order treat as one unit. Now there are how many remaining 3 will be go means 7%. 7 plus this 1 unit, total 8 units will be occur. These 8 units can be arranged in 8 factorial. A1, A2, A3 is always in the same method, same manner. So that is why in the only one way they can be done. So total number of ways is 8 factorial. This is the question number 8. So next go to the question number 9, 10. This is the question number 9. Okay. Find the number of ways in which 5 red balls, 4 black balls of different sizes can be arranged in a row. What are they? 5 red balls, 4 black balls. Find the number of means that is totally how many you get? 9 things, 9 balls. You can be arranged in 9 factorial. But in the question is given that so that first one is no two ball of the same color come together. This is the restriction type 1. So no two balls of the same color come together. No, no one not. So that is why first arrange them is any one of the balls. So first I am taking the 4 black ball. 1, 2, 3, 4. That is the black ball, black ball, black ball, black ball. No two of them in the same color they are asking. So first to arrange the black balls. Black balls. How many are there? 4 black balls. So not come to that means we can find in between them gaps. So in before that 4 balls can be done in how many ways we can done it? This can be arranged in 4 factorial ways. Either B1, B2, B3, B4 and B2, 3, 4. D2, 3, 4, 1. Like that how many we can get? 4 factorial ways. And how many gaps in between them you can find? 1, 2, 3, 4, 5. In plus 1 only. That means 5 gaps. How many gaps? 5 gaps. Why? Because taking gaps, gap method, no to never together means always gap method should be applied. If it is come together means make a bundle, then continue the process. It here given that never come together. So should be take the gaps only. Gap method you have to write. So first arrange the black balls. 4 black balls are there. It can be done in 4 factorial ways. Now we can find 5 gaps. In these 5 gaps, we can arrange the red balls. We can arrange them with red balls. So how many red balls are there? 5. So 5 balls can be done in 5 places. That is nothing but 5p5. Arrange them 5p5 or else 5p5 nothing but npn. npn is in nothing but n factorial or else here 5p5. 5p5 are same or else same thing 5 factor. Both are same. So in these 5 gaps we can arrange with 5 red balls. So that is meaning that 5 factorial ways. Therefore, the total number of arrangements are 5 factorial into 4 factorial. So that is the answer. What is the question is given that in the 5 balls, 5 red balls, 4 black balls. So how many we can arrange means total 9 factorial. That is never asking. First question is given. No two balls of the same color come together. So never come together means find out by gap method. Come together means treat as a one unit. Treat as a one unit. So first we arrange 4 black balls. Arrange them in a row. So it can be done in how many ways? Nothing but 4 black balls means you can arrange them is 4 factorial ways. Now gap method means you can find in these in between gaps we can find. In these 5 gaps, how many balls with the red balls? Red balls we have to arrange them. In these 5 gaps, to fill 5 red balls in 5 factorial ways. Therefore, the number of ways in which no two balls of same color come together is 5 factorial into 4 factorial. That is, answer is 5 factorial into 4 factorial. That is the question number 9, first bit. And the second one is the balls of the same color come together. Same method and all those are same. It will be come together means take as a bundle. That is the process. Not never come together means you can find the gap method. You should be found in between the gaps. You can fill up with the remaining things. That's all. The second bit goes to second bit. The balls of the same color come together. So come together means always the common topic is come together means you can treat as a one unit. So treat as a one unit means 5 red balls as one unit. 4 blacks are one unit. How many are these? 2 units. 2 units nothing but it can be done in 2 factor. Why means first arrange suppose 5 red balls with 4 black, that is first one way. Or else 4 black and 5 red, that is the 2. So nothing but 2 factor means nothing but 2 method. 2 factor 2 into 1, that is 2. 2 means how many? First are arranged with 5 red or 4 black, or else 4 black and 5 red. That is the 2 ways. That's why 2 units can be done in 2 factorial ways. That is the first red ball, 5 red balls can be treated as a 1 unit. 4 black balls can be treated as a 1 unit. So there are 2 objects. These 2 objects can be arranged in how many ways? 2 factorial ways. Why? Because first arrange with red or black or red. This is 2 objects with 2 ways. That is nothing but in the form 2 factorial. Now the balls of the same color come together means first red balls can be permuted among internal arrangement, that is 5 factorial. 5 red balls mean ball 1, ball 2, ball 3, ball 4, ball 5. They are not in that same order. In that order. Should not be in that order. Not. So let us take a sign. It can be permuted internal arrangement of the 5 red balls as how many ways we can get, that is 5 factorial ways. In similarly, the black balls are 4. Internal arrangement of the 4 black balls, internal arrangement is nothing but 4 factorial ways. So therefore the total answer is 2 factorial into 5 factorial into 4 factorial. So that is the question number 9. Ninth question. So always in the come together means you can do as a make a bundle. No should not come together means you can use gap method. That is the remember, that should be remembered. All those similar problem up to 6th, 7th, 8th, 9th, 10th also same. No two balls of the same color come together means you should first arrange the black balls in a row. It can be done in how many ways? 4 factorial ways. Now we can find how many gaps in between them? 5 gaps between them. In these 5 gaps you can arrange with 5 red balls. That is 5 gaps, 5 red balls means it can be done in 5p5, or else in NPN nothing but n factorial. That is by 5p5 nothing but also we can write as 5 factorial. 5 balls, 5 places can be arranged in 5 factorial. So total ways is nothing but 4 factorial into 5 factorial. In the same way, the balls of the same color come together should not come together only giving. Second question is given that. So come together means you have to take it as a unit. That is a make a bundle. That's all. So that is 5 red balls as treated as 1 unit, and then 4 black balls can be treated as 1 unit. Totally, this 1 unit, this 1 unit means total units are 2 units. That is 2 factorial ways we can select it. But in the 5 red balls internal arrangement, in that order should not be always in the form that. So ball 1, ball 2, ball 3, this is not in the same order. So it should be convert as in internal arrangement permutation will be occur. That 5 red balls can be permuted in how many ways? 5 factorial ways. And 4 black balls can be permuted among themselves in 4 factorial ways. Therefore, the total arrangements are 2 factorial into 5 factorial into 4 factorial. This is the question number 9 second bit. So this question number 10 also is in the same similar pattern. You should you do yourself, Nana. You get an idea. You can solve that question. Okay. So always practice all those. Just don't forget that this gap method and make a bundle. That is always come together means you have to take it as a bundle method. Never come together means you treat it as a gap method. That's all. So next question will be try do yourself. Okay. Thank you, Nana.